The James Webb Space Telescope has recently made a groundbreaking discovery that is causing a stir in the world of physics. With just one stunning image, it has challenged long-standing debates in cosmology, leaving scientists astonished. This new discovery marks the end of theories and is set to completely change our view of the universe. In this article, we will explore the discussions that this image has finally settled and how it is reshaping our understanding of space. One of the major problems in astronomy is that scientists can't agree on how old the universe is or how quickly it is expanding. This mystery has puzzled researchers for centuries, leading to countless studies trying to find answers. Cosmology is the study of how the universe began, how it is structured, how it has evolved, and how it might end. Over the last century, the field has made great progress, and the leading theory, known as the Big Bang Theory, suggests that the universe has been expanding for around 13.8 billion years. This expansion is measured using something called the Hubble constant, which shows the rate at which the universe is growing. However, measurements of the Hubble constant are not straightforward, and there is a big difference between two main methods of measurement: local measurements and those from the early universe. Local measurements involve studying objects like stars and supernovae to calculate the universe's rate of expansion by analyzing their brightness and speed. On the other hand, early universe measurements focus on the cosmic microwave background, CMB, which is the faint radiation left over from the Big Bang. By studying the CMB, scientists can estimate the age and expansion of the universe. The problem is that these two methods don't give the same results. Local measurements suggest the universe is expanding faster than what the CMB data predicts. This inconsistency has left scientists wondering whether we are missing something, or if there are errors in our measurements. Thanks to the James Webb Space Telescope, we can now observe distant parts of the universe with incredible clarity. It can see objects that were once thought impossible to observe, such as small galaxies and distant planets. Many hoped that the telescope would help us settle the debate over the Hubble constant, but the initial data has only made things more complicated. The new insights challenge our current understanding, which might lead to a new theory about the universe and force us to reconsider some of our ideas. For example, we might discover particles and forces we've never seen before, or it could mean that dark energy, the mysterious force driving the universe's acceleration, needs to be rethought. Throughout history, new discoveries have often changed how we think about the universe. In 1965, the discovery of the cosmic microwave background radiation strongly supported the Big Bang Theory. Before that, scientists believed the universe was eternal and expanding at a steady rate. But then, in the late 1990s, we learned that the universe is actually expanding at an accelerating rate, which led to the discovery of dark energy. Every time we make a new discovery, we question whether it fits with our current ideas. If it doesn't, we develop new ways of thinking to improve our understanding of the cosmos. The current challenges in cosmology could lead to some of the most profound discoveries yet. One ongoing mystery in cosmology is the Shapley strain, which refers to how matter is spread out across the universe. In some regions, galaxies are closely packed together, while in other areas, they are more spread out. Researchers use various methods to study this, such as observing how light from distant galaxies bends when passing near massive objects, a phenomenon known as gravitational lensing. This can help us learn more about dark matter, which doesn't emit light but has a gravitational effect on visible matter. Another tool is the cosmic microwave background, which provides a snapshot of the early universe, over 13 billion years ago. However, when we compare the CMB's measurements of matter distribution with what we observe through gravitational lensing, the results don't match. The CMB shows that early matter was more evenly spread out, while gravitational lensing shows the opposite. This suggests that there is something we still don't fully understand, possibly related to dark matter. The James Webb Space Telescope is helping to address these questions. Its high-resolution images will help scientists study the universe's early stages, such as the first galaxies and stars that formed. This could help refine our measurements of the universe's expansion and matter distribution. These questions require precise observations and might lead to new theories. Whether we discover more about dark energy, new physics, or even dark matter's behavior, the implications could be vast. One recent effort, called Project Flamingo, uses a supercomputer in England to simulate the universe's behavior. With over 50 million hours of computing time and 30,000 processors, this project aims to understand dark matter and how it interacts with galaxies and other cosmic elements. Project Flamingo uses a more comprehensive approach than previous simulations, including galaxies with unique gas contents, stars, and black holes. It tries to reconcile different views of the universe and improve our understanding. However, challenges persist, and we still don't have all the answers. The universe is like a giant puzzle, and scientists are still trying to fit all the pieces together. The James Webb Space Telescope is giving us sharper images and more data, which is both exciting and overwhelming. Despite these advancements, some questions remain unanswered. The universe seems reluctant to give up all its secrets, but as we continue to gather more information, we get closer to solving its mysteries. Since Edwin Hubble's discovery that the universe is expanding, we've made rapid progress in understanding the cosmos. From the Big Bang Theory to the discovery of dark energy and dark matter, we've learned a lot, but there's still much to uncover. New discoveries and observations continue to shape our understanding of the universe. Each breakthrough brings us closer to understanding the cosmos and our place within it. In the past, it was believed that everything in the universe revolved around the Earth. But figures like Copernicus and Galileo changed that view, showing that the Earth and other planets orbit the Sun. Later, in the 20th century, Einstein's theory of relativity revolutionized our understanding of space, showing that space and time are interconnected. In 1920, Hubble's observations revealed that galaxies were moving away from each other, leading to the formulation of the Big Bang Theory. Scientists once thought that gravity might eventually stop the universe's expansion, but the discovery of dark energy has shown that the universe is expanding faster than we thought. Today, researchers are still trying to reconcile discrepancies in measurements and understanding. One example is Project Flamingo, which aims to merge different approaches to cosmic research. Despite its complexity, this effort is part of the larger goal of understanding the universe's expansion and the behavior of dark matter. As our telescopes improve and our simulations become more advanced, we are constantly refining our understanding of universe. Each new discovery opens up new questions, and each answer brings us one step closer to solving the puzzle of the cosmos. The James Webb Space Telescope's new findings challenge existing theories and suggest that our understanding of the universe may need to change. With every discovery, we move closer to uncovering the profound mysteries of the universe and our place in it. The motivation behind ambitious projects like Project Flamingo is clear: to explain cosmic conflicts where the measurements appear flawed and do not fit into the structure of the universe. This discrepancy in measurement suggests a fundamental misunderstanding in our current understanding of the universe's operations. If these measurements could be compared to musical genres, they are like jazz and classical, each having its own technique though still related. Flamingo attempts to merge these different perspectives and refine our individual impression of the universe. However, despite its complexity, the vast tension persists. This strain continues to exist as a humbling reminder that we have yet to solve much of the mystery that surrounds us. The universe seems reluctant to reveal its secrets to us, but just like that, as we add each new data point and simulation model to our toolkit, such as Flamingo, an increasingly vast new universe opens up with new challenges to address. That is a never-ending mission, where each answer leads to more questions, revealing an entirely different layer. It shows us that the nature of our curiosity to unravel the universe's mysteries is complex and ever-changing. Since Edwin Hubble made his groundbreaking discovery of the expanding universe in the early 20th century, the pace of our understanding has been extraordinarily rapid. Scientists are constantly making new discoveries about the dynamics of the cosmos, such as the Big Bang Theory, dark matter, and dark energy. They have explored the universe by studying the cosmic microwave background and carefully recording the positions and speeds of galaxies with ever-increasing precision. Each of these achievements is like acquiring one more key piece of the enormous puzzle. This has led to a drive to learn and strive for a greater understanding of the universe. Indeed, the universe is cloaked in mystery, and it can be dangerous to uncover its truths too quickly. With every scientific step, researchers propose refined hypotheses, altered models, and more precise questions. The theory posited by the Big Bang Theory was once highly controversial but is now considered a major part of scientific knowledge. Similarly, dark matter is no longer a speculative thought, but an undeniable key element of our astronomical puzzle. The discovery of dark energy, an unexplored cosmic force driving the universe's expansion, was a late 20th century revelation and is now one of the fundamental building blocks of our understanding of the universe. Let us now explore the various ways researchers have attempted to solve the conundrum of the universe's expansion over time. They have worked tirelessly, yet some of the pieces simply haven't fallen into place. In the past, it was commonly accepted that every object overhead, from the sun to the stars and all the planets, revolved around the Earth. This geocentric view was challenged by the likes of Copernicus and Galileo, who held that the Earth and other planets orbited the sun, introducing a revolutionary perspective. Fast forward to the 20th century when Einstein introduced a new, revolutionary view of the physical world. He proposed a model where existence is not made up of isolated substances but rather a four-dimensional structure called spacetime, where everything is interwoven. His discoveries gave the universe a dynamic nature. In 1920, Hubble's observations revealed that galaxies were moving away from each other, showing that the universe was expanding. With this reality, researchers formulated the Big Bang Theory, which suggests that the universe arose from an initial singularity and has been expanding ever since. The possibility that gravity would eventually end the inflationary cycle was accepted. However, Flamingo faces challenges in reconciling the clumpiness seen in the CMB with that in the local universe. Errors persisted between the universe's expansion rate and the distribution of matter, leaving cosmologists searching for explanations. Some predict that new physics and laws beyond our current understanding will be necessary to explain these inconsistencies, while others believe our measurements or understanding of dark energy may be flawed. This attention is a classic example of history repeating itself, with the universe itself serving as the central mystery. To summarize, the capabilities of the latest telescopes and advanced simulations have barely resolved the puzzle. We are now at the edge of the cosmic precipice, where the unknown is hidden. Yet the endless quest for knowledge is one of the wonders of science. Every question opens another door to the infinite search, and with every trial and simulation, we move closer to understanding the universe's vast mysteries. The James Webb Space Telescope, with its advanced capabilities, has provided us with incredibly sharp images and data that add layers of complexity to existing tensions in cosmology. It uncovers galaxies that appear more scattered than our current theories had predicted. Despite ongoing efforts, including elaborate simulations like the Flamingo project, intended to integrate both normal and dark matter impacts, there remains a discrepancy. Flamingo aims to reconcile our theoretical models with observational data, but the universe continues to be surprisingly resistant. So where do we stand now? Our models of the universe are undergoing significant challenges, possibly signaling a paradigm shift where our theoretical foundations may need to be reassessed. These challenges are not accidents but rather signs guiding us toward a deeper understanding. Every discovery is added to another, upon which researchers refine their ideas or hypotheses. Each new tension or inconsistency offers some clue that science and our comprehension of the universe must be corrected. The steps of the universe change like no other, with the details being shaped by some strange force. Despite the many complexities involved, there is a persistent desire to explore and understand what we have, keeping us on the path of discovering new mysteries about the universe. To approach the edges of the seemingly endless universe, where consciousness becomes blurred and ambiguous, is to face conditions that challenge us to imagine new ways and concepts for understanding. Each new observation that defies our model serves as a hint that could lead us to new physics, offering new explanations for the fundamental workings of the universe. The essence of science lies in its self-correcting nature. Every revelation builds upon the last, and each anomaly or tension prompts us to refine our theories and our understanding of the universe. The scientific investigation of the universe remains an ongoing endeavor, driven by the advent of cutting-edge telescopes, increasingly refined simulations, and a community of dedicated researchers focused on uncovering its secrets. The universe isn't just a wilderness. It is the ultimate puzzle, and solving it represents one of humanity's most magnificent and exhilarating challenges. As we embark on this cosmic journey, it is important to stay curious and engaged with each new discovery. With each new understanding, we edge closer to grasping the wonders of the universe.